Hello folks, we come to the miscellaneous exercise of this chapter 3 of matrices. The first 2-3 problems, they have to be done by principle of method of induction. They have given you the matrix A, which is given as in the board. You've got to show that AI plus BA the whole raised to n is A raised to n I plus n A raised to n BA. This is to be done by principle of mathematical induction. So we know we do it in 2 steps. So let's start right away. Let Pn represent the given mathematical statement. The given Step 1 is to show that P of 1 is true, right? So that in a sense AI plus BA whole raised to 1 is A raised to 1I plus 1 A raised to 1 minus 1 BA. Now for showing this, let's consider the RHS. A raised to 1I plus 1 A raised to 1 minus 1 BA. A raised to 1 is A itself, so AI plus A, this is A raised to 0, which is 1 into 1 BA, right? And this is equal to, you could call it as AI plus BA raised to 1 is the same, so that is the LHS. So starting from the RHS, you have reached the LHS, therefore P of 1 is true. We go to step 2, where we assume P of K is true. Assume P of K is true, which means that it is AI plus BA whole raised to K is actually A raised to Ki plus K A raised to K minus 1 dA. To show that P of K plus 1 is true, which means AI plus BA raised to K plus 1 is A raised to K plus 1I, K plus 1 A raised to K BA, right? So maybe you can start with the LHS. The LHS, which is AI plus BA whole raised to K plus 1 by law of indices, can be written like this, isn't it? A raised to m plus n is A raised to m into A raised to n. So like that you can separate it. Why we are doing this? Because you can use this. Okay, so from 1, this can be replaced as A raised to Ki plus K A raised to K minus 1 BA into AI plus BA. You can open these brackets and see what is coming. A raised to Ki multiplied with this. So A raised to K and A will multiply, it will become A raised to K plus 1. I into I we always know is I. So that's the first thing. Next is, this is multiplied by this. So A raised to K B A I, right, or I A. Then next is this getting multiplied here. K into A raised to K minus 1, A raised to 1, A raised to m, A raised to m into A raised to n is A raised to m plus n. You can add up the powers and it will go to, so it will become K A raised to K B A into I. Last term, K A raised to K minus 1 B into B is there, so B squared and A into A. Yeah, so how these terms are coming up, let's see. Only thing, this term will become 0. Why? Because you look at A, it is given as 0, 1, 0, 0. So if they say A into A means we are multiplying 0, 1, 0, 0. Check what happens. On matrix multiplication, first term is 0. First row, first column, first row, second column, that's also 0. Then everything is 0, so it's a 0 matrix. A squared is 0 matrix. As a result, you can have like this as 0. And how about the remaining? A raised to K plus 1I. Look at this, exactly identical. right? So you can take that common out. A raised to k b a I common. Here nothing is remaining 1. Here remaining is k. So k plus 1. And that's exactly our RHS. Let's check. If you want, you can write a reason. A squared is 0. I can show the working also if you want in the bracket. So that's it. A raised to k plus 1 plus a raised to k b a I, of course you can eliminate, and k plus 1. Yes, so that's the RHS. Therefore p of k plus 1 is true. From steps 1 and 2 by the result is good. Okay. Then we have this matrix A, and you have to show this. That also goes by induction. So like before, let's call this as a statement. Let Pn be the given mathematical statement. Right. And step 1, to show that a raised to 1, to show that p of 1 is true, which means that it is a raised to 1 equal to 3 raised to 1 minus 1, 3 raised to 1 minus 1, 3 raised to 1 minus 1, 1 minus 1. Yeah. So for that, let's consider the RHS, which is all that. 3 raised to 0, 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 which is all 1. We know that anything raised to 0 is 1, and which is k, and which is RHS, right? Sorry, LHS. And that's how p of 1 is true. Then we go to step 2. Assume p of k to be true. So what do we assume? We assume that a raised to k is 3 raised to k minus 1, 3 raised to k minus 1, 3 raised to k minus 1. Yeah. We assume this to show that is true, which means to show this. So let's consider the LHS. A raised to k plus 1. So that is, we all know it's a raised to k into a. So that is 3 raised to k minus 1. We get it from 1. For us it is, we had seen that a is 1, 1, 1. Otherwise also it's given. So let's matrix multiply and find out. First row, first column. 3 raised to k minus 1, 3 raised to k minus 1, 3 raised to k minus 1. Every entry is going to be like that. Yeah? They are all going to be the same. 3 raised to k minus. Now check this. This is common. So it comes out. 3 raised to k minus 1 comes out. As a result, 1 remains everywhere. So what will happen? This will get converted into 3. So 3 raised to k minus 1 into 3, a raised to m into a raised to n, a raised to n plus n. So what will happen? It will become 3 raised to k net of it. Now it's the same everywhere. All these entries are the same everywhere. Finally, this is coming as 3 raised to k, 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 which is the RHS. This is shortage of place, I'll just write here. Therefore, p P of k plus 1 is true. Therefore, by principle of mathematical induction, given Pn is true. That's all about this video. In the upcoming video, we will be taking the remaining problem. That is also there also we'll have induction problems. Couple of induction problems are there in this exercise. So that will be seen from there. Thank you.